It really is that easy when we set up our equations properly. All we have to do is add. Hey folks, Steve the Math Buddha here, and today we're going to look at a variation of a common work rate problem that I see floating around the net. It's one of those how long will it take them to paint a house if they all work together questions. And in today's video, I'm going to show you how easy it is to solve these kinds of problems when we set things up correctly. So let's bring up the problem now. In today's problem, we are given that Amy and Brian paint a house in 4 days. Brian and Chris paint that same house in 5 days. Chris and Amy paint the house in 6 days. And the big question, how long will it take Amy, Brian, and Chris to paint the house if they all work together? Now, before we go on to the solution to this problem, I just wanted to remind you all that if you like my videos, please show it by liking, sharing, and subscribing, and turning on those notifications so that you will know when future videos are coming out. Now, one mistake that people often make when they try to solve this problem is they take an expression like this one and they want to turn it into a plus b equals 4. But that just doesn't work. You know why? Because we're given days per house, and days per house is just not additive. When people work together, time goes down, not up. Time doesn't accumulate. And this brings us to the main issue we have with this kind of rate problem. And that's that the rates we're given are inverted. We don't want time per unit of work. We want work per unit of time. Work per unit of time is additive. If you paint a house a day and I paint a house a day, together we're going to paint 2 houses per day. Time is the constant element here. When people work together, the implication is that they're all working for the same period of time, which means that we want our rates expressed over a common unit of time. And you know what? Our unit of time doesn't have to be a day. We could choose any unit of time that works for our problem. And the unit of time that I would like to use for this problem is 60 days. Why 60 days, you ask? Well, the reason why is because 60 is the least common multiple of 4, 5, and 6, which means that the number of houses each one of our pairs will paint in 60 days will be an integer. And I do prefer working with integers whenever I can. So, given our outstanding selection for a unit of time, why don't we set up our variables accordingly? Let A be the number of houses painted by Amy in 60 days. B will refer to the number of houses painted by Brian in 60 days. And let C refer to the number of houses painted by Chris in 60 days. Next, let's go back to our original statements and translate them into this new language. We are told that Amy and Brian paint a house in 4 days. That means that they will paint 15 houses in 60 days. We just multiply through by 15. And the way that translates is A, the number of houses painted by Amy in 60 days, plus B, the number of houses painted by Brian in 60 days, equals 15. Next, Brian and Chris paint a house in 5 days, which means that they're going to paint 12 houses in 60 days. And we can write that as B plus C equals 12. Finally, Chris and Amy paint the house in 6 days, which means that they will paint 10 houses in 60 days. And we write that as C plus A equals 10. Now we need to find A plus B plus C because that's the combined work done by our 3 workers over 60 days. So what we're going to do is we're just going to add all our expressions together. It really is that easy when we set up our equations properly. All we have to do is add. Just take a look at the left-hand side of this equation. You will see that each of our variables appears twice. 2 A's, 2 B's, and 2 C's, which means that when we add everything together, on the left we're going to have 2 times A plus B plus C. And on the right, we just have to add our constants together. So we get 15 plus 12 plus 10 equals 37. Now we just have to divide by 2 to get our A plus B plus C isolated on the left side. And that's going to give us A plus B plus C equal 37 halves. Translation, Working together, Amy, Brian, and Chris will paint 37 halves of a house in 60 days. But you know what? That is just not going to cut it, because our final answer has to be in days per house. So what we're going to do next is we're going to multiply through by 2/37. Note, when we multiply this by 2/37, well, they're reciprocals, so we're just going to get 1. When we multiply this by 2/37, we will have in the numerator 2 times 60 equals 120, and in the denominator we will have 37. Translation, working together, Amy, Brian, and Chris paint a house in 120/37ths of a day. But you know what? We're not quite there yet. We really want to pull out whole days out of this fraction. So what we're going to do is we're going to divide the 37 into the 120. Now 37 times 3 is 111, which means that 37 divides 120 3 times with 9 left over. And the way we express that as a mixed fraction is 3 and 9/37. And that's our final answer, folks. Working together, Amy, Brian, and Chris will paint the house in 3 and 9/37 days. And that's it, folks. That's how we solve work rate problems where we have to find a combined rate from the individual rates. Now, I hope you liked my video. Please let me know in the comments what you thought, what you liked, what you didn't like, what you might like to see in the future. Please, any problems that you'd like me to solve, let me know in the comments and I will take a stab at it. And by the way, what do you think of my t-shirt? Unfortunately, the t-shirt is not yet available for sale, but if you need an original design for anything, I strongly suggest that you reach out to my Fiverr artist. As usual, I have a link to his Fiverr page in the description below. And I have an obligation to tell you this, that is an affiliate link, so any first-time purchase you make on Fiverr through my link will get me a commission. And that's all I have for you, folks. I am the Math Buddha, and I am signing off once again. Have a great night and have a truly pleasant tomorrow.